So a lever is a straight or a bent rod which can be moved about an axis. So this is the definition of a lever. And then there is principle of lever. Now, principle of lever, a lever can be, it works on the principle of moments. Okay, we have already seen the principle of moments. So that is, we have seen it in the first chapter. So I'll just revise that with you again over here. So this is a lever, which is a straight or a bent rod, and it can be moved about an axis. So let's say here is our axis, and this axis point is called as a fulcrum. So this is fulcrum, and a lever is used to move a heavy load. So here is the load, and you apply force to move that, and so that is the effort. So L stands for load and E stands for effort. Okay, now there are two new words that I'm going to introduce. One is called as the load arm, and that I am writing it as L arm over here. And if I call this point as A and call this point as B, so that is equal to FA. Then another term that I'm going to introduce to you is effort arm, that is E arm over here, and that is equal to FB. To the principle of moments into load arm is equal to effort into effort arm. Load upon effort is equal to effort arm upon load arm. But what is load upon effort? So MA is also equal to effort arm upon load arm. I want you to tell me that when will MA be equal to 1?
So when the fulcrum is in the center and the load arm is equal to the effort arm.
Okay, very good. And what other condition should happen?
So when if there are weights, then the weight has to be equal on either side.
Okay, very good. So MA equal to 1. So let me write it in red. So that implies that load is equal to effort. And it also implies that effort arm is equal to load arm. MA greater than 1. What will that imply? When can MA be greater than 1? Like MA is 2, 3. When will that be possible?
If the load is greater than the effort. Yeah, the effort arm is greater than the load arm.
So that means MA is load upon effort. That means load has to be greater than effort, and effort arm has to be longer than the load arm. Okay. Now here we have MA less than 1. So what will that imply?
That
load is less than effort, and effort arm is smaller than the load arm. So now what we have is, what is the meaning of MA greater than 1? What is the meaning of MA less than 1? Like if a machine has a mechanical advantage more than 1, less than 1, equal to 1, what does that mean? So I'm going to write that over here. When MA is greater than 1, the machine acts like force multiplier. It is less than the load. So you have to move a heavier object and you can do a load. So you have to move a heavier object and you can do that by applying a lesser effort. When MA is less than 1, it acts like a speed multiplier. That means whichever machine acts like a speed multiplier, that means it is helping you to do things faster, has mechanical advantage less than 1. And when MA is equal to 1, it acts like